Alright, looks like we're live. We are trying the new ultra low latency setting today, so hopefully there will be less of a delay between the chat and my video. So, should be more like it's live today. So while you guys are jumping in, I'd like you to type in the chat, what are you doing to keep yourself busy at home? I'm losing my mind for sure, and would love to know what you guys are doing to keep yourselves busy. So type it in the chat. How have you kept Give everybody a couple minutes to jump in before we get going here. Such a nice day outside. I will not be hurt if nobody shows up. My neighbor is cutting their grass. Hopefully the sound isn't too bad. Looks like it might be picking it up a little bit. I should put some music on while I'm waiting here. What's a good, like, waiting to get started song? Hey, Diamond, how's it going? Let's go put some music on while we're waiting. You should put It's Raining Tacos. That's my favorite song. Raining Tacos. Love that song. I haven't had a taco in so long. It's making me go crazy. Let's see if I can play this. Oops. Diamond, what are you doing to keep yourself busy? Is it playing?
Raining tacos from out
Love
of
this
the
song.
sky. Tacos, no need to ask why. Just open your mouth.
Listen to the lyrics of the song. It's like the best.
It's raining tacos. It's raining tacos. Out in the street. Tacos. All you can eat. Lettuce and shells. Cheese.
I feel bad for the people that are just jumping in right now.
It's raining tacos. Yum, yum, yum.
Can you hear the music?
Yum, yum. It's like a treat.
It's the best song ever.
Yum, 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 yum. Bring your sour cream.
Shell, meat, lettuce, cheese, shell,
It's the best song ever.
lettuce, cheese,
We'll get started when the song's over.
cheese, cheese, cheese.
So other than watching
cheese,
TikToks, what else?
It's
Let me turn this
raining
down.
tacos. Raining
Other than watching TikToks, anything else? Watching any good shows on Netflix?
raining tacos.
Anybody seen The Tiger King?
It's raining tacos.
I don't know why the chat is no longer showing up on my live stream. It was working, and then it just all of a sudden stopped working.
Lettuce, cheese, shell,
Alright. That was fantastic. I love that song. It always puts me in a good mood. If I'm ever in a bad mood, I'll put the taco song on. Although it makes me think about tacos and how I can't get tacos right now because everything's closed. Alright, well, let's get rolling here. So, I sent an email out to everybody. Suspenseful movies. I sent an email out to everybody this morning, and I talked to some of the science teachers yesterday, and we are definitely going to be putting the brakes on how fast we've been teaching. So we're going to be slowing stuff down. And what I'd like to do too is to do a Zoom check-in with you guys once a week on Fridays from 1 to 2. So this would be instead of my normal YouTube live stream. I would have like a weekly check-in where we could all see each other and we could talk, and it would be almost like we're at school. So I'd like to try that this Friday. I sent an email out with instructions, and I will send another email out Friday morning to remind everybody. You basically just click on the link, and it'll pull it up on your computer, and you'll get to see everybody. So it's going to be mixed up all the classes, both chemistry and physics. From what I've heard from other teachers, it sounds like, you know, maybe 10 to 20 people will show up. So we'll see. I think we can do better than that. The other thing I asked you to do this morning was Google Forms quiz. Not a quiz. Don't want to use that word quiz. Google form just to check in and see how you guys have been doing. So I sent you that via email this morning. If you didn't get it, let me know. But I think it went out to everybody. It should be in your inbox, your school email. So please fill that out. Let me know how you're doing. the people that I don't hear from, I'm probably going to follow up with just to make sure that everything's okay at home. Definitely worried about you guys. I had a couple people send me emails yesterday to give me an update on things that are going on. So I know there's quite a few of you that are dealing with things at home. I had one student tell me that they're not feeling well, and of course my mind immediately jumps to, oh man, they probably got COVID. So hopefully that's not the case. So just give me an update. Let me know how you guys are doing. Let me know if there's anything I can do to help you guys out. All right. It is Virtual Spirit Week. If you watch my video from today, I've been playing Fallout. It's a cool game that I've been saving for a while. It's a post-apocalyptic game, and you basically try to survive in a nuclear devastated environment. And it's a little scary because I know that what we're going through right now is not the same as a nuclear disaster, but if something like this if we had a much worse virus where it wiped out a bunch of people and everything was just abandoned, I could kind of see it being the same thing. So, you have to band together with the other survivors and plant vegetables and build things and try to survive, and zombies are attacking you and stuff. It's awesome. So I posted a video of me playing that. It sounds like Diamond has been binge watching a lot of movies. What's a really good movie that you've been watching on Netflix or Hulu or whatever? What's a good suspenseful movie that you've seen? If anybody else is in the chat and wants to chime in on what you've been doing, feel free. Love to know what you guys have been up to. I'm going crazy not being able to see and talk to you guys like we used to in class. Well, she is typing. I'm going to keep going through my stuff. Oh, before I forget, tomorrow is TikTok Challenge Day, so be sure to tag me. If you want me to try and do whatever TikTok dance it is, you have to do it first. That's the only rule. I'm happy to try and replicate a dance. I know that I think Yoselin told me she was going to tag me in a video, so I'm anxiously awaiting her video so that I can try and copy it. Only Mine. I have not heard of Only Mine. I'll have to look it up. I'm going to write it down, though, because I'm running out of things to watch. Only Mine. And I'll just put Diamond Says It's Good. Okay. So yeah, if you want to participate tomorrow, I do not have a TikTok, but I think if you make a video, you can email me the link and I can look. They really frown on us having TikToks, but I could definitely find your video, I think, on TikTok. So just send me a link, and I think I can find it that way. Or just email me the video, and I'll try to replicate it. We'll figure it out. We'll figure it out tomorrow. You got to do the dance first, though. All right. For physics, I posted the test today. So it's a Google form. It's not in Safe Examining Browser. We are not using the district assessments for eLearning. We're basically using an assessment that the physics teachers kind of put together. So I think it's going to be a little bit easier for you guys because you have the flexibility of being able to use your notes, and I think it's just going to be a little bit easier for you. So you shouldn't have as much anxiety taking it as you would normally in school. I'm not watching you while you're taking it. So it's open today through the 8th. If for some reason you have an issue where you can't log in and take the test, let me know because that deadline's flexible. So I know a lot of you guys have things going on at home. So if something's going on where you can't take the test by the 8th, let me know and we can figure it out from there. Test is multiple choice, and you can take it as many times as you want to try to improve your score. I gave you a review guide. There were 2 parts to that review guide, so you can go through the review guide. I worked through the entire review guide. Monday I did part 1. Yesterday I did part 2. So I've been posting the live stream each day on my website. I just kind of put it at the end of the post, so you can go in there and find the review guide. The other thing, if you're having trouble with anything in the review guide, you want some extra help, don't forget I have tutoring available. You just go to that website that I linked you and book an appointment, and I will use Zoom, and we can do a one-on-one video conferencing session, and I can see your screen. You can ask me questions. I can try to work them out for you, and you can see my screen. So that option is available for you. Please take advantage of it. All right, I have some good news for you, for my physics people. We are not doing anything else for the rest of the week. Basically, I want to give you Thursday and Friday to get yourselves caught up, whether that means in my class taking the exam, If you need to retake the exam, you have time to do it. And then, of course, I know that you guys have other stuff to do for other classes. If you're completely caught up in my class, please use Thursday and Friday to catch up in your other classes. As teachers, we're all trying to figure this out. So anything I can do to help you guys, so we're all caught up, and maybe next week we can all start off like we know what's going on, kind of thing. So that's the plan. All right. So since we already reviewed, and we're not covering anything new, I thought we'd do something fun today. I thought we would do circuits in Minecraft. So I know Minecraft's a little old, but you guys all have the Education Edition on your computers, I believe. So the question we're going to try to answer today is, are circuits in Minecraft accurate? If you've never played Minecraft before, that's fine. But I've played it before with my kids, and maybe even by myself. All right, I'm not going to lie and say that I've never played Minecraft before. It's a very entertaining game. I like how it's open-ended and you can do whatever you want. I loved Legos as a kid, and Minecraft is kind of like virtual Legos. So we're going to be looking at some circuits in Minecraft, and we're going to be seeing if they are very accurate, because you can make circuits in Minecraft using redstone. So we're also going to be using the circuit simulation that we've used in class. So we're going to kind of compare the two. So we'll make it in the simulation, the FET simulation, and then we'll make the same circuit in Minecraft and see if it's accurate. Because I can tell you that the FET simulation is very accurate. So let's try doing some circuits in both. So let me get Minecraft rolling here. All right. This is so exciting. Love Minecraft. Oh, it didn't do it right. It's supposed to be creative. It put it in survival. Let me redo this. I'll bring it over so you guys can see it in just a second. I don't want you to see my gamer tag and then try to hit me up. Alright, and we want creative, world type flat. Alright, I think I got cycle and always day. Okay, I think I got it right. Cross your fingers. There we go. Oops. Sweet. This is so exciting. How many teachers can use Minecraft? Diamond, you are not the only person watching. It says 3 people watching right now. So even if it's just us, we'll have so much fun. Don't you worry. Okay, so here is our world in Minecraft. And let me bring up the simulation. So the first thing that we're going to try to do is we're going to try to build a circuit with a light bulb, a series circuit. Okay, now remember, in series circuits, the disadvantage is that if you break the circuit, the rest of the things in your circuit stop working. So let me pull up the simulation. Why is Siri talking to me? All right. I like the music in the background. That's nice. Let me just turn that down a little bit. All right. So let's build a series circuit in here. So we've got our battery, we've got a light bulb, and let's do it like this. Okay, so there's our series circuit. We got a light bulb to work. Now I'm going to basically take the same circuit and I'm going to recreate this circuit in Minecraft. So let's do this. Okay, so I'm going to find redstone. Where's a redstone block? So I need a redstone block. This is going to act as our battery. And then I need redstone, which is going to act like the wires. And then I need a redstone lamp, which is going to act like our bulb. Okay, so let's go ahead and drop a battery. And then for a series circuit, it's just a loop. Oops. My OCD is kicking in a little bit right now because there is a missing block of grass there, and it's really bothering me, so I'm going to put it back in. Ah, so much better. All right, so we need to add a light bulb now. So let's take our series circuit and let's drop a light bulb in right here. So notice we've got our power supply, which in this case is going to be the redstone block. Functions the same way. And we've got our wires going around in series, and then we have our lamp. My God, there's another one. This game's messing with me. All right, so as we take our circuit path all the way around, you can see that it goes to the bulb, and the bulb is on. So if I put another bulb next to it, you can tell that this is on, this is not. All right. So far so good, right? Our series circuit matches up. Now, let's take a series circuit and let's add another bulb. Because we know one of the disadvantages of a series circuit is that when we break the circuit, so like right now both bulbs are working, okay? But if I were to break the circuit here, in a series circuit, both bulbs will go out. Okay, so let's go ahead and break the circuit here. Both bulbs went out. All right, so I'm going to do the same thing in Minecraft, and let's see if that happens, if it functions the same way. All right, so I've got one bulb. Let me move this over a little bit so we have some room. Diamond, do you play Minecraft? It's okay if you do. No judgment. I love Minecraft. Minecraft is so much fun. I was trying to think of something cool that we could do today for physics, and I'm like, oh, we should play Minecraft. All right, so let's put in one here and one here, and then let's connect them. So everything's good so far, right? We got our two bulbs. They're both lit. Just to give you an idea, there's a non-lit bulb right there, so everything's good. So let's try turning one of these bulbs off. Let's break the bulb, and let's see if the other bulb goes out. Okay, because remember, in a series circuit, if you break the circuit, everything downstream stops working. So I broke the circuit. I mean, clearly you can see that the circuit is broken right here, but right next to the, just to give you an idea, you can tell that this bulb is still functioning, whereas this one here is not. So already we can tell that there's a problem with Minecraft because it's not functioning like a normal circuit would. Okay, if this were an actual series circuit, because the circuit is broken here, this bulb should go out as well. All right, so series circuit, it failed the series circuit test. All right, let's try a parallel circuit now. So go back here. So remember, parallel circuits, they have multiple branches like this. Okay, so we've got our battery, our power supply. We've got our first branch right here with the resistor, which would be our bulb. And then we have another branch right here with another bulb. All right, so let's try to make this first in our circuit building simulation, and then we will, let me just reset this, and then we'll do it in Minecraft. So we got our battery. Let's do one bulb here, one bulb here, and let's wire this up. So here is our first branch, and if I connect this, everything should light up. Oh no, what happened? Did I do this backwards? I might have done it backwards. Don't want to start any fires. Again, almost burned the school down. What is going on? Don't start any fires. There we go. I don't know what I did wrong. Just had it connected wrong. Okay, so we got our first bulb connected. Now let's go ahead and connect our other bulb. Boom. Okay. Now with parallel circuit, remember you've got multiple branches. You can see everything's flowing. Both bulbs are the same brightness. In a series circuit, remember they kind of split the amount of current that each bulb gets. but in a parallel circuit, they're the same brightness. So let's try to recreate this in Minecraft and see if it's accurate. All right, so I've already got one branch here. Let me reconnect this, and let's try to do another one. All right. Diamond, I don't think you're watching anymore because I asked you if you played Minecraft and you didn't say anything. All right, so we've got everything connected here, and it looks like one bulb is on, but the other is not. So what's going on here? When I did this earlier, I had them both lit. There we go. Maybe just wasn't enough juice to travel. Okay, so we've got our battery here. I added another redstone block. I just didn't think there was enough juice to power both, which is a problem because in a normal series circuit, or sorry, normal parallel circuit wouldn't matter. All right, but here I had to add another redstone block, so they're both lit. Now, in a normal parallel circuit, if I were to take one of these batteries out, if I break the circuit, the other one should stay lit. Let's see if it passes that test. So I'm going to go ahead and break this circuit, and it does stay on. So it looks like it passes the test. Okay, now there's one more thing I want to go through here. In each branch, we can make each branch kind of like its own series circuit. Give me a second to set this up. So I'm going to put 2 bulbs in each branch instead of just one. Go like this. Alright, so you can see these 2 bulbs right here are, this is still a parallel circuit, but this branch right here has 2 light bulbs that are in series. Okay. I'm not going to do anything with the other branch here, but now in the circuit, if I were to cut the circuit right here at the first bulb, what's going to happen to the second one? What do you think is going to happen here if I cut this bulb? Nobody's paying attention. That's fine. It's fair. I get it. It's a really nice day out, honestly. It's a good thing my computer's not facing the window because I would be looking out at the wonderful weather we're getting right now. Okay, so I'm going to go ahead and cut this, and are we going to have a test on this? Yes, the test is today. Did you not see the post for today, Talia? It's good to see you, by the way. I don't think I've seen you on a live stream yet. So even though this is a parallel circuit, because I broke the connection here, this whole branch stops working. Oh my god, what happened here? Simulation's a little buggy. There we go. Yeah, so let's try to do this in Minecraft. You didn't see the post for today, so let me pause for a second. And let me post the link for the post from today. If you went on Hack, you should have seen the link as well. Here is the post for today. So if you click on that, that should take you to the instructions for today. And then the normal page that you should bookmark on your computer. So every day I'm updating this. So that second link, if you click on that, bookmark that on your computer. Every day that's where I'm posting updates. So the things that you have to do. You can kind of scroll through them. Like here, I'll pull it up here. So you can scroll through, and they're by day. So if you ever miss a day, you can go here and just kind of go backwards. So this is what we're doing today. This is what we did yesterday, Tuesday. This was Monday. This was before spring break. So you can just kind of go backwards, all right, if you missed anything. And the other way you can tell what day it was for is you can look right here. It tells you right under the title the day that it was for, okay? So if you have any questions about anything, just shoot me an email, all right? Or I can even, if you want, I think I gave you guys my the contact number that they gave me. My phone number, if you want to call me, the phone number that you can call to get a hold of me is this one right here. I don't know if you can read that. It's 779, I'll type it in the chat, 779 379 1392. Okay, that's a Google Voice number. So it's not my personal cell phone. It's just a Google Voice number that I'm using for e-learning. You can call that number, you can text to that number, and you can ask me questions, okay? Or if you just want to tell me what you're watching on Netflix, just, hey, Mr. Zorn, this is a really good show. You should watch this, okay? So it works just like Remind. It'll pop up on my computer, and I can respond to you guys there, all right? So feel free to hit me up anytime on there. All right, let's finish this up before we hit chemistry. So let's try to build a circuit like this in Minecraft and see if I disconnect one of these branches if both lights go out, all right? And then here we go. So we've got our parallel circuit, so I'm going to add another bulb here. So we'll do a bulb here, and we'll do a bulb here. And remember, in my circuit simulation, I broke one of the bulbs, and both bulbs stopped working. So let's see if that's the case here. So if I break this first bulb, see if the second bulb goes out as well. And it does not. So, as you can see from Minecraft, if we were to go back to our question and answer it, are circuits in Minecraft accurate? The answer is definitely no. They are not accurate. I have to see, because there is an education version of Minecraft. I was playing the actual version of Minecraft, but I know there's a couple things that are supposed to be more accurate in the education version, but the normal version of Minecraft, the circuit knowledge that you should have from physics does not coincide with actual circuits in Minecraft. So they're not the same. They're similar. There are some things that work the same, but they're not quite the same. So there you go. So that's all I had for physics. Anybody have any questions? Otherwise, I'm going to wrap up today, physics, and then move on to chemistry. Natalia, did you find everything that you needed to on that page? Are you still there? While she's typing, I just want to remind you guys, tomorrow's that TikTok challenge. If you want to, you have to do it first. Do a video, do a TikTok video, and send it to me. I will do my best to try and do it myself. I actually today recorded my video for tomorrow, and I had my daughter try to do a dance with me. I'm doing it right now. Awesome. So I had my daughter do the dance with me. So if you check in tomorrow, even though for physics, like I said, we're not doing anything else for the rest of the week, I'm still going to make my daily post on my website. So if you check in, you can see my Spirit Day updates. And then on Friday, I want to remind you that we are doing that Zoom check-in from 1 to 2. It's optional, but if you guys jump in on that, you'll be able to see your classmates. I'm not covering anything physics or chemistry related. It's just an opportunity for you guys to come in and see me and interact. So I'm excited to see you guys. For those of you that show up, it should be a lot of fun. And that's it. So if you guys don't have any other physics related questions, I'm going to kind of change over to chemistry. We'll give everybody that is waiting, or everybody that's jumping on it for chemistry, a couple minutes to hop on. So let's see, I know Diamond's here, Natalia's here. Who else is in chat? There's only a couple of you today. Let me close Minecraft. Anybody else in here today? It's super nice outside. I'm definitely going to have to go for a walk later. It's awesome. It's like the first good day we've had in a long time. I also have groceries coming today. I'm super excited about that because we're almost out of like real food. We have to like go into when I was trying to buy groceries, one of the last days that you could still go out before the quarantine, like they were all out of meat. So I had to buy Spam. Spam was like the only meat that was available. So I bought a bunch of Spam. We haven't had to use it yet. Some people really like Spam. I'm a vegetarian, so I don't eat Spam, but the rest of my family eats meat. So we've had that for emergencies, and fortunately, or maybe unfortunately, we haven't gotten to that point yet. I don't know. My kids have never had Spam before. Anybody like Spam? S-P-A-M? Not the junk email, but the food. It's a good time to be a vegetarian because I don't have to eat like weird meat, the leftover meat. How are you guys doing on food and everything? Everybody have food to eat at home? You're not like eating newspaper or anything because you're out? I know the school's been really good about providing meals for people. So if anybody's having any issues with stuff like that, definitely let me know, because I think there's some resources through the school we can get you guys hooked up. All right. So we'll give everybody until about 1:32, and then we will get rolling here. I should play Minecraft while we're waiting for people to jump in, because Minecraft is awesome. I should try to build. I should try to recreate the school in Minecraft really quick. Creative. Did you guys know you had Minecraft on your computers? Where is mobs? Oops. It'd be so funny, the people that jump in after the fact. They're gonna be like, what the heck is Mr. Zorn doing? Let's see, the school's made out of stone, right? So I should probably use stone. Cobblestone. This is gonna be awesome. And let's start building, right? Already screwed up. Oop. I'm not very good at Minecraft, I'm not gonna lie. And we have to start chemistry in like 2 minutes, but this is gonna be awesome. Look at this. Oops. Right? How am I doing? Am I doing good? This is like the best Minecraft model of the school ever made right here. It's gonna be. It's been so long since I've been there, I don't even remember what it looked like. Something like that, right? Sure. Like, nobody's saying anything in the chat. I feel like I'm just talking to myself right now, but that's okay, because like when I'm normally teaching, I feel like half of you aren't paying attention anyway, so this makes me feel like I'm back at school right now. Alright, let's see here. Isn't it something like that? I honestly don't remember what the school looks like at this point. Let me see here. Should maybe get a picture of it. Building. Right? Looks like that. It's pretty much just a giant rectangle, right? Oh, it's got this part, the new addition. That's kind of a weird part of the building. But, oh, it's 1:32. Let's get rolling here. Okay, so, chemistry. Those of you that are joining me for chemistry, I would love you to type in the chat what you are doing to keep yourself busy at home. I feel like I'm living the same day every day. Feels like the movie Groundhog Day. Pretty much consists of me waking up, doing school stuff, talking to the other teachers, planning the stuff out, talking to you guys, and then I usually help my kids with stuff, make dinner, go to bed, and then do it all over again. It's the same thing every single day. It's pretty monotonous, and not being able to go out and do anything, I'm losing my mind. So I'm sure you guys are experiencing the same thing. I would love to know what you guys are doing to keep yourself occupied and keep you from not going crazy at this point. There's only so much you can do. There's only so much you can do on Netflix before you like run out of good shows to watch. So it's good to know that you guys are feeling the same way, because oops, let me close this. I think that maybe doing like a weekly chat where we can see each other would be awesome. Don't get me wrong, I like live streaming, but I feel like I'm lacking that two-way interaction with you guys. So anyway, so this morning, those of you that are just joining me, I sent out a link to a Google form I'd like you to complete. Just check in with me and let me know how everything's going. You should have gotten it in your email. If you didn't, let me know, and I can send you the link. I'm going to do this every week just to make sure that everything's okay with you guys. The people that I don't hear from, I'm probably going to follow up with. I really want to make sure, I'm really concerned about you guys. I want to make sure that everybody's okay, everybody's got food, you know, that you guys are safe, basically. I was talking with Mr. Jern, one of the other physics teachers this morning. Like he and I are both, like I couldn't sleep last night because I had a student tell me that they're not feeling well. Like they're starting to have some of the symptoms. Hopefully it's not COVID. It's maybe just the flu or something else. But that's the kind of stuff that keeps me up at night. I'm worried about you guys. I want to make sure that you're okay. So if you could do me a favor and check in on Google Forms, and if you're able to come on Friday and talk with me, that would be great. Like I said, we're not going to do anything school. We're just going to basically hang out and talk about stuff, catch up, because I'm definitely missing that interaction, and I'm sure you guys are too. All right, so Virtual Spirit Week. Today is Quarantine Made Me Day. So what you were supposed to do is post something that you're doing at home. I posted a video playing Fallout, which is an awesome game. Those of you who have never played it before, I highly recommend it. It's very addictive. It's a post-apocalyptic game, and you're basically wandering around trying to survive. So you're like finding other survivors, and you're like building. You're taking like you're trying to like scavenge for like wood and metal and build structures, and then like zombies will come attack you, and you have to protect yourself. It's awesome. So highly recommend that game if you haven't played it before. That's what I'm doing. I'd love to know what you guys have been up to. Tomorrow is TikTok Challenge Day. I would love for you guys to send me a challenge to do. I'm, like I said, losing my mind and would love to try to make you guys laugh. So if you can do a TikTok dance or video or something, it doesn't have to be on TikTok. If you just do some like dance video or whatever and email it to me, and I will actually sit there and give it a good shot, and I will do my best to try to make it happen. I recorded the video for tomorrow already today with my daughter. She's really into TikTok dances right now, so oh man, what was the song called? Sunday's Best, I think it's called. She had this whole dance number that she did, and I was trying to follow along with her. So tomorrow, if you check in, you will see the video, and it's pretty hilarious. So I would love to try to do that for you guys if you have a video. But you have to do it first, okay? All right, so for chemistry this week, basically we covered heating and cooling curves Monday and Tuesday, and then I told you that I would give you today through Friday to catch up. So if that means finishing the calorimetry lab from before spring break, use the time to do that, or complete the 2 lessons from Monday or Tuesday. All right. As I said yesterday, or maybe today, I don't remember because I feel like I'm saying the same thing over and over again. We're really, really slowing down the pace that we're teaching class. I know a lot of you have things going on at home, so we're doing our best as teachers to try to make it manageable for you, because I get that some of you are probably watching siblings, helping out around the house. I know a lot of students are working right now, like grocery stores. I know quite a few people are working at Walmart, so I get that you guys have other things going on. So we're doing our best as teachers to try to make it manageable for you. So please use that time to get caught up, and then on Monday we'll kind of pick up with some stuff, but it's going to be at a much slower, much more manageable pace than before. All right? Now that we know we're stuck at home until April 30th. All right, so what I'd like to do for chemistry is go through one more heating and cooling curve, and then I have a cool simulation that I want to show you. So this is kind of what we've been talking about. This is a heating curve of water. So we know there's 3 states to pretty much anything. You've got a liquid state, a gas state, and a solid state. So for water, when it's really cold, it is in the solid state here. Luca Gaming. Sorry, dude. Okay, who's Luca Gaming? I got you in one of my classes. It's probably one of the chemistry classes. So yeah, solid ice when it's cold, and then when you warm it up, when you apply some heat, it becomes a liquid, and then finally it will become a gas after you've applied a lot of heat to it. All right. So you just need to be able to read one of these curves. That's kind of the goal for this week. And what I'd like to do is show you this simulation. Let's see if I can get this to pop up. All right, so let's go through the different states of matter. I want to give you just a better idea of what's going on with these. Okay, so let's switch this to water. All right, let me switch this to Celsius since that's what we've been talking about. So for the state of water, when it's cold, it's ice, right? So as you can see, The temperature in my container here is currently negative 127 degrees Celsius. All right. So you can see all the water molecules right here. They're not moving very much, and they're all kind of stuck together in the same arrangement. All right. So this is the solid ice. I know it doesn't look like ice right now, but this is like zoomed in at the molecular level. So if I go down here and I start to apply heat, remember on our curve, once we start to apply heat, it's going to transition into the liquid state at, anybody remember what the transition state of water is, where it goes from ice to liquid? There it goes, creeping up, creeping up. It is coming up to 0. So at 0, we start to transition into the liquid state. All right, so now you notice the molecules are no longer kind of staying in that shape. Now they're kind of moving around a little bit. So I'm going to continue heating. Notice how the molecules start to move a little bit more the more heat we apply here. There's 40 degrees Celsius, 50. Okay, they're moving around a little bit more. Okay, remember at 100 degrees Celsius is when water starts to turn into gas, liquid water. You can already see some of the molecules starting to fly up. Okay, so we've passed the 100 degree mark. Now all of those water molecules are starting to float into the air. They've got a lot of energy. Okay, so this would be like water steam. Let's really crank this up. Look at them go now. They're going crazy. Look at that one up there. It's like flying all over the place. Isn't this fun? This is like the most fun I've had all week with chemistry. Look at those molecules flying. So that's what's really going on when we're transitioning states. Right? Now if I go the opposite way, so if I try to cool this down, so here's my gas, right? We're at 261 degrees Celsius. Let's try to cool this down. So we got ice. So remember, at 100 degrees is where we transition between gas and liquid. You said not really. Doing the best I can. All right, so once we get below 100, we're going to start coming into, this is basically liquid water again. It's starting to condense. Getting cool. So much fun. All right, so when we get to 0, remember, is where we transition into a solid. So now it's kind of stuck as a solid. So this would be like water in your cup frozen. Yeah, the colder we get, the less the molecules move. So we're at negative 270 roughly degrees Celsius. Look, it's frozen solid. Molecules aren't moving. And I can add heat and it goes back up. So the more heat we add, the more it moves, the more kinetic energy it has. I guess that's the whole point of even showing you guys this. All right, let's keep going. Yesterday we talked about how to draw one of these curves. Okay, these are the steps. We always start by labeling our axes. Temperature is going to be your y-axis, and reaction progress or energy is going to be your x-axis. And then diagonals are temperature changes. Plateaus, or the flat parts of the graph, are where we transition between the states. Okay, the units for temperature are always going to be Celsius, not Fahrenheit. Celsius, not Fahrenheit. And then reaction progress can be time. If you use energy, it's going to be joules. Okay. We want to make sure when we graph this, we leave enough space below the melting or freezing point, and we leave enough space above the boiling or condensing point for our graph. All right. So what I'd like you to do, if you want to follow along with me, you can. If you want to do this with me, you can. In your OneNote, if you look under homework, you'll see this. It's not homework, it's just practice. But if you can do this, you can do anything. All right. We're going to scroll to the 3rd page. There's a practice. Yesterday I did a heating curve. Today I'm going to do a cooling curve, which is the opposite. So let me pull it up on my end here. All right. So you want to go to the 3rd page. So this is page 1, page 2, which is what we did yesterday. Page 3 is the directions. Okay. So I'm going to try to pull this up so you can see the directions and the graph at the same time, so bear with me for just a second. Drawing curves. All right. Okay, so if you want to do this with me, you can. If you want to just watch, that's cool too. So this is the 4th page where you actually have the graph. And I don't think there's any way, let me see if I can make this bigger. There we go. Okay, so you can see the graph here. and you can see the instructions on the right. This should be in your OneNote if you are following along. And I'm going to go through how to complete this cooling curve. Alright, so our steps. The first step when we're drawing any of these is to label our axes. So we're going to label the y-axis as temperature. And the units for temperature are degrees Celsius. Alright, and then our x-axis, we're going to use energy. And why are my cats fighting? Fighting over the best spot by the window, I guess. Okay, so energy, and the units are joules. Alright, it can be energy or it can be reaction time. Either one's fine, they're interchangeable. Okay, so looking at the directions here, it says draw, this is not the right one, we want this one. It says draw a cooling curve that has the following information. The y-axis should start at 0 degrees Celsius, the y-axis should end at 210 degrees Celsius. Right? The boiling point's at 150, the freezing point is at 90. So, when you want to scale your y-axis, you want to pick numbers on your y-axis where it kind of takes up the whole thing. All right. So just looking at those numbers, I could go by a really small number. I could go by 1, but I would need 210 different marks, and I know on my graph here I have 25 spaces. I could go by 2s, but again I would need about 105 spaces, which I don't have. I have 25 spaces. So what if I went by 30? So every mark on the graph would basically be 30 degrees. So looking at those numbers, 210 divided by 30 would be 70, or 7. Yeah, 7. Can't do math. All right, 150 divided by 30 would be 5, and then 90 divided by 30 would be 3. Okay. So I have 25 spaces on the graph. So let's see, 210, 7, just doing some math in my head. All right, so 210 is the biggest number, and if I divide that by 30, it was 7. So there are 25 vertical boxes on my graph, and if I divide that by 7, that's roughly every 3 boxes. So let's do this. So every 3 boxes on my graph, I'm going to make a mark, and I'm going to go all the way up. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so let's see if I did this right. So 0, 30, 60, 90, 120, 150, 180, 210. And what do we go up to? 210. So I have 1 extra mark on there. That's okay. All right. So it's saying the y-axis should start at 0. The y-axis should end at 120. So we're good. Or 210, sorry. The boiling point is 150. The freezing point is 90. So I'm going to draw dashed lines across the graph at 90 and 150. So at 90, let's draw a dashed line all the way across. Oops. And 120, or 150, sorry. All right. Now, this tells us that it's a cooling curve. Okay, because it's a cooling curve, we know that we're going to start in the gas state, which is a high temperature. So the first point, the first transition point is going to be 150. So I'm going to draw a flat line on my graph at 150. And we're starting at 210. So I'm going to basically go from 210 down to that flat line right there. And then the next transition point is at 90. So I'm going to draw another flat line here and connect them. And then I'm going to take my last spot here and basically go down to 0. Alright, so let me kind of explain what I just did, because that was a lot. So it says the boiling point is at 150. So I'm going to highlight that in yellow. So that plateau is where we're changing from gas to liquid, or liquid to gas. Alright, let me label these on the graph here. So this is where we are a gas. This is where we're a liquid, and then this is where we are a solid. All right, it says the freezing point is at 90. So let me highlight that on my graph. So that other plateau is the freezing point. It's also the point where we melt, where we go from solid to liquid, right? Those are the same points. Anywhere on our graph where we are at a diagonal is where we are changing the temperature. So we are not changing states. So like for example down here where we're in a solid state, you can have an ice cube at 0, but until you hit, or not an ice cube, sorry, because we're not necessarily talking about water here. Whatever this is in its solid state, you can continue to heat it, and it's not instantly going to turn to liquid. It won't start to turn to a liquid until you hit 90 degrees. All right. At 90 degrees, it's going to start changing from a solid to a liquid. All right. That's why you have that plateau on the graph. That's the point where it's changing. All right. So it says label the phase changes as either melting, freezing, boiling, or condensing. All right. So at this point right here, we have 4 points basically. Let me do these in a different color so it's a little easier to see. So I've got this point here, this point here, this point here, and then this point here. All right. And then we've got melting, freezing, boiling, condensing. All right. So when we go from gas to liquid, so gas, you can't see it. Let me make this a little bigger. So when we go from gas to liquid, that is called condensing. All right, so I'm going to mark this point right here as C. So that's where we start to go from gas to liquid. All right. When we go from liquid to gas, that is called boiling, or we'll say evaporating. Okay, so I'm going to put that point right here. So if you're following along on my graph here, why didn't that update? Great, my OneNote's not cooperating right now. Let's try this again. Love it when things don't work right. It's fantastic. It's like, what else can go wrong? If this doesn't pop up, I will just do it with the mouse. I actually have 2 computers up at the same time, so I will draw on my tablet and it will update on my desktop. But for some reason today, it's giving me grief. It doesn't want to do any work. It's like it's too nice outside. I don't want to do anything else. Kind of mentally there too right now. I don't want to really, I want to go outside and enjoy this wonderful day. Okay, it's fantastic. I'll just do it with the mouse. All right. So when you go from a liquid to a gas, I apologize, my handwriting's going to look terrible right now because I'm doing it with the mouse. When you go from liquid to gas, that is evaporating. I'm going to abbreviate because it's so painful to try and do this with a mouse. Evaporating, and that's going to be right here. All right. Let's see, what else do we need to label? When we go from liquid to solid, so liquid. Oh, this is so painful. Liquid to solid. All right, liquid to solid is called freezing. Think about ice. Freezing. Look at that. That's like, you can't even tell I did it with a mouse. It looks so good. All right, so freezing. All right, and then when we go from solid to liquid, so solid to liquid. This is painful. I'm so sorry. That liquid didn't look so good. Solid to liquid is melting. All right, there you go. So when we go from solid, when we hit this point right here, that's where we start to transition to a liquid. So that is where we begin to melt. All right. This point here, when we're in a liquid state and we're going to solid, this point right here is where we start to transition to solid. So that's a freezing point. For liquid and we start to turn into gas, that is evaporating. That's this point right here. And then if we're a gas and we start to turn into a liquid, that's where we hit that condensing point. Okay? So hopefully that makes sense. If it doesn't, type in the chat and I will try to clarify. So answering these questions, I think we already did a lot of this, but the melting and the melting point would be at 90 degrees. 90. Okay, so you're just following the plateau over to the y-axis here. What is the condensation point? The condensation point is at 150. Just matching up that plateau to the y-axis. Which line segment shows a phase where both liquids and solids exist? Okay, so at this flat point right here, it's between liquids and solids. All right, so I'm going to put F and M. So it's between the freezing point and the melting point. Which line segment shows a phase where both liquids and gases exist? So it's a gas here, it's a liquid here. So on this plateau is where it's the same. So between the condensing and the evaporation point. At which point does the liquid phase begin to decrease in temperature? Okay, so at this E point right here is when it would be decreasing in temperature. So at point E, we're done turning from gas to liquid. At point E, it will start to drop in temperature. At which point does the solid phase begin to decrease in temperature? Kind of the same thing. So at point M, we're done turning from liquid into solid. At point M, we can just continue to freeze, or we can continue to drop the temperature on that solid. So at point M, the temperature is going to drop. During which line segments are there phase changes? Anytime you have a plateau or a flat part of your graph, there's a phase change. So that's C and E, or from C to E, and then from F to M. All right, and then the last question, during which line segments are there decreases in kinetic energy? Include all that apply. Okay. Anytime you're on a diagonal on the graph, you have a change in temperature. So if you're matching it up to the y-axis here, you notice as you start to go down this line on the y-axis, you're dropping in temperature. So any diagonal, you have a change in kinetic energy. So like the simulation that we watched today, if you notice as we dropped the temperature, those molecules started to move a little bit less. As we increase the temperature, the molecules move more. So the higher the temperature, the more kinetic energy. So let's see, so that's going to be basically any diagonal here. So G, L, and S, I have them labeled. So when it's a gas, a liquid, or a solid. Any questions? I only have one person watching still. Is that still you, Diamond? Diamond, you're my hero if you're still watching. I think I lost everybody. It's just like normal class. Maybe I should do a dance or something the last 5 minutes of my live stream just to keep people from dropping. All right. If you don't have any questions, I'm just going to go ahead and wrap up then. So I just want to remind you, tomorrow is the TikTok challenge. So if you're going to do a video, you have to do it first though. All right. Do the video first. You can send it to me. You can just email it to me if you want. Or I'm not super familiar with TikTok. I don't have a TikTok account. But if you, I don't know if there's a way for you to post it on TikTok and then send me the link via email. I'll find out. My daughter knows everything about TikTok. And then the other reminder is Friday from 1 to 2, we have our Zoom check-in. Don't have to come. I would love for you guys to come, though, and meet with me. So there will not be a live stream on Friday. We will just have the Zoom check-in. All right? And that's pretty much the plan for the rest of the week. Friday's pajama day. Yep. That's all I got for you guys. So if you don't have any questions, I'm going to go ahead and wrap up, and I will see you guys tomorrow. If you have questions, shoot me an email, and that's basically it. It's good to see all of you guys today. All right.